Assalamualaikum and a very good day to our Vehicle Brake System lecturer, Professor Madya Dr. Muhammad Zahir bin Hassan. Today, we will present our laboratory assessment titled Identifying a Brake System Component. This is our group members starting from Muhammad AZAHAR bin Muhammad Noor, next NADZIRAH binti MUHSIN, Muhammad NABIIL bin NOOR HISHAM, Muhammad QAYYUM bin Muhammad FUAD, and finally AHMAD NUKMAN bin JAMALUDIN. Before we start, we want to pray for your speedy recovery. May Allah is everything for you. Okay, let's start. The car that we were using was an automatic transmission BMW 3 Series E36 model and 328i variant made in 1997 that have 2800 cubic capacity engine with registration number ADV 5550 belong to Mr. Iskandar. Now, we will proceed with our finding.
This is brake pedal. We can see there is long leverage arm here. It gives driver a nice mechanical advantage. When pressed, it applies the brake, causing the vehicle to slow down or stop. At the top here, we have wiring system. It has a stop light switch or stop light sensor that took control of the brake lights. At this sensor, we can see there are 4 wires harness. The red one is for brake light and the blue one is for automatic gear shifter lock solenoid. The brake booster is assigned to increase the brake performance by increase the force exert. This is master cylinder. Inside the master cylinder, it have 2 springs and 2 pistons. There is label at the master cylinder which is V and H. V is for the front and H is for the back. This is brake reservoir. It is equipped with brake fluid switch fluid. Here is the valve that separates the brake fluid into front wheel and rear wheel. This brake system we call dual split brake system. The valve is connected to ABS motor, and ABS motor is assigned to controlling and temporarily releasing brake pressure to prevent locking during braking.
Next, we need to remove the tires so we can do inspection on the brake caliper. This car is using disc brake on all 4 tires. Firstly, we need to loosen the bolt of the wheel using torque wrench according to the crisscross pattern. Now, we are using a tool called lifting jack to jack up the car to help us with removing the tires. Then, a hydraulic floor jack is used to help us lifting up the front side of the car. Afterward, the bolt need to be removed from the tire so that the wheel can be pulled out. When pulling out the wheel, we need to be careful because wrong technique can cause serious injury on our back. After the wheel has been removed, slide it down underneath of the car for safety reason, in case both of the jack stand fail.
So we will do brake identification for brake disc type. This is the brake rotor. The brake pad and caliper rubs against the rotor and create the necessary friction to slow down the disc. in turn slow down the wheel and vehicle. Next is the brake caliper. The brake caliper houses your car's brake pad and pistons. This is the brake pad. The brake pad and its caliper create friction as they rub against the spinning rotor. To slow down, the brake pad retainers secure the brake pads in the exact position within a brake caliper, and the inspection hole is to inspect whether the condition of the brake pad and the caliper is in a good condition. And this is the brake line, which transfer brake fluid between the master cylinder and wheels when the pedal is pressed.
Hi, my name is Muhammad NABIIL, and I'll be talking a little bit about the braking system that exists within this car that we chose. If you look at the sketch here, this is the braking system that exists in the vehicle that we chose. This car uses disc brakes instead of drum brakes. One of the more noticeable features on this braking system is the presence of caliper, which does not exist in drum brakes. But how does the brake work? In this illustration here, the brake pedal is pressed by the driver, and that generates pressure within the brake booster to push the brake oil towards the piston. This pressure pushes the piston, and the piston in turn pushes the brake pads, causing them to clamp onto the rotor disc. This generates friction, and the brake discs, which are attached to the wheels, loses its energy in the form of heat, and the car loses its speed. One of the electronic brake system in this car is ASC, otherwise known as Active Stability Control. It is part of a stability control system to improve the stability of your vehicle. It is slightly different from traction control, although both of them do work hand in hand in keeping your vehicle stable. You can see the ASC light light up on your dashboard. Depending on your vehicle design, the ASC light can be seen as the letters ASC like this, or in triangular caution shape like this. So, whether it's called ESC, ASC, DSC or VDC, they are all designed for the same purpose, which is to improve the stability of your vehicle. Stability control cuts power and applies braking force on the wheels to position the car to where the driver is intending it to be. Its main purpose is to cut understeer and oversteer. In an oversteer situation, the ESC will apply brakes on the outside wheels, and in an understeer situation, the ESC will apply brakes on the inside wheels. However, it is to be noted that this system only works for your vehicle's designated wheel drive. For instance, if you are driving a front wheel drive, then it only works on your front wheels. If you are driving a rear wheel drive, it only works for your rear wheels, and the same is true in an all-wheel drive.
Today I'll present about question B. Okay, this question say the difference of a dual split brake system and diagonal split brake system. The difference is, first of the dual split brake system is the circuit act on the front wheel and one rear wheel with one hydraulic. Another one of diagonal split brake system, the left rear and right front are one hydraulic, which the right rear and left front are one circuit. The difference is easy wheel to skidding and possible losing control. So for the diagonal split brake system, easier to driver to control the vehicle in emergency brake failure. The question is the difference of oversteer vs understeer. You can see the diagram show that normal drive is follow the corner, but another one understeer is go hard to different angle. We can see the we can see the diagram, they are at a different angle of the wheel. And on the left one is a normal drive, and understeer and oversteer. The difference of oversteer is between understeer is the difference of oversteer and understeer is when the rear wheel do not track behind the front wheel, but the slide out toward the outside of the turn. And for understeer, when the front of tire do not follow the eastern trajectory, the driver is trying to impose while taking the corner. Instead, the following a more straight line trajectory. Next, another difference is oversteer can be corrected by the stiffness the vehicle front chassis. Another steer is can be corrected by stiffening the vehicle rear chassis. Okay. The last one is calculation. The calculation, we can put that which, as you know, the brake system that takes the kinetic energy to off moving vehicle and convert into terminal energy through the friction. And the main function of brake system is slow down vehicle speed and stop a moving vehicle when needed, also keep the stationary when parked. And as we know, the brake system is the one of the best safety mechanical system to avoid accident happen.